All right, hello. We're going to talk about factors and prime factorizations, and we're going to find factors of a number. And when a number is multiplied to find a product, each number is called a factor. So the factor numbers of 45 are what? 9 and 5, 3 and 15, 1 and 45. All those numbers are factors of that 45 of the product, okay? We're going to go to the next thing. Identifying prime and composite numbers. A prime number, it is one and itself. So 2, 3, 13, 7, and 37 are all prime numbers because only 1 and 2, 1 and 3, 1 and 13, 1 and 7, 1 and 37. Hence, it is one in itself. But the composite numbers, they have multiple factors, okay? So 12 has 1, 12, 2, 6, 3, 4, right? 25 is also composite because it has 1, 5, and 25. Not just 1 and 25, but also 5. So these would be composite numbers. All right, prime factorization is the factorization in which all factors are prime numbers. Prime numbers. So they ask you find the prime factorization of 45. You would break it down into a factor tree. It's the easiest way to do it. You put 45, then 5 times 9, and then 9 breaks down to 3 times 3. And what are those factors? 5 times 3 times 3. And then they just want you to take the 3 and make it 3 squared. So it's 5 times 3 squared. That would be the prime factorization, and this would be the answer that they would be looking for. So I made a couple little samples here. Use a factor tree to find the prime factorization of 18, and 80, because I put 80 up there for us to work on together, okay? So 18, I did 2 times 9, and then the 9 breaks down to 2 3s, and then you have 2 times 3 times 3, and then the final answer is 2 times 3 squared. Not so bad, right? But 80, we could do a couple things with the 80, right? If I did 4 times 20, that's still 80. But then I can break these out. Remember, we're breaking them down till we get to the prime numbers where we cannot have any other numbers that can be reduced, right? So this would be 2 and 2. And this could be 2 and 10. Okay? And these all get multiplied together. Then 2, 2, and 2 are all primes. We're good with that one. But 10 breaks down to 2 and 5, right? So these are the 4 2's and then 1 5. So 2 to the 4th power times 5. That would be your final prime factorization of 80. Gotcha. Next up is simplest form of a fraction. You have to reduce the fraction. You have to think of those factors, hence factors, right? That's what we're talking about right now. The factors of 8 and 12 to reduce down to the prime numbers that you can't reduce anymore. So we have, I believe, 4 goes in each of those. So we do 4 times 2 and 4 times 3. And then we would just cross those off, and we would have 2 over 3. And that's the simplest form of 8/12 would be 2/3. That's reducing a fraction. They tell you to reduce it to simplest form. That means that that's what they want. They want the lowest terms. And then equivalent fractions is if they're equal or not, right? If you needed to find out if these were equal, I'm going to show you how to do that. You're going to do, all right. So we're going to reduce these first and then find out if they're equivalent. So if I take them down to the simplest form, 8 times 2 and 8 times 5, the 8's cancel out and I have 2/5 left, right? 10 and 25, I believe 5 goes into both of those. And then 5 times 5, right? And then I'm going to cancel those out. Well, lo and behold, what do I have? 2/5 and 2/5. We were able to take them to the simplest form, and they both equal, hence the equivalent. So yes, they are equivalent. Not too bad, right? Not too bad. However, let me just add another little page here that if you needed to find out if two fractions were equivalent, I can tell you that you can do cross products of them, right? You can do cross products. If I needed to know 6/24 is equal to 2/8, I could cross multiply. Six times 8 is 48, and 2 times 24 is 48, and 48 equals 48. Then they are equal, so yes, they are equivalent. Nice. Nice. And I believe that ends this lesson. So go back, rewind, check it over, and go from there. All right, thank you. Take care. Have a great day.